Howdy and welcome to my video on the unit circle and angles and metric functions. Okay, so in this video I will be going over the unit circle and how you can determine the values of trig functions using it. I will also be talking about types of angles such as reference angles and supplementary and complementary angles. The problems I am using, or the one problem I am using, is from the Virtual Math Learning Center. I will put a link to that one, to the problem in the description. This first problem, though, where I will draw the unit circle, is me testing myself. Okay, so I'm going to start off with a circle. Circle. And I'm going to roughly divide this into two. It's probably off a bit for some reason, but whatever. Okay. So we know that in our x direction, right, this is cosine. And in our y direction, we have sine. For each of these, let me do a different pattern. Okay, so probably the most notable, or the easiest one to remember, is when your angle is pi over 4. Apologies. Okay, so the pi over 4, if I can draw. So at this angle, right, and when we talk about angles, we're talking about from 0, right, and going outwards this way in a counterclockwise angle. This is 0, you have pi over 2 over here, right, and you have pi, 3 pi over 2, and you end up with 2 pi, or just 0. Excuse me. So anyways, so for our angle of 45 degrees, or pi over 4, and I'll use radians. Okay, so pi over 4, you get root 2 over 2, comma root 2 over 2. And the only difference is when you go to the next one, right? So we add 90 degrees, so we get 3 pi over 4. Or 90 degrees would be pi over 2, right? Now that we are in this region, we have a negative cosine, positive sine. So this is negative root 2 over 2, root 2 over 2. We get down here to 5 pi over 4. This is double negative region. So we have negative pi over 2 over 2 and negative pi over 2 over 2. And finally, for 7 pi over 4, this is a positive negative region. So we have positive root 2 over 2 and then negative root 2 over 2. This process repeats for pi over 6 as well. So when we draw pi over 6, it's not to scale, I'm just drawing so I have enough space. It's right like this. It's kind of like this somewhat. So closer. It's like around here. Say there, and then around to here. Okay. Notice that we have this like bow tie effect, right? That these angles are the same distance away from the x. Now this is where I want to introduce a concept of a reference angle. So if you're in the first quadrant, right, you'll probably remember what the value is for a certain angle because you're all taught the first quadrant. But what if we're in the second, third, or fourth quadrant? You can figure out what the absolute values are supposed to be. So let's say we had 5, 5, or 4, right? So we can find the angle from the nearest point of the x-axis. So go here to here, right? And this is just pi over 4. So the reference angle for this angle is pi over 4. And we know that we will use the values that pi over 4 has. So root 2 over 2, root 2 over 2. And now we have just to look at, oh, what region are we in? What quadrant are we in? We're in the third quadrant, so it's double negative. Okay? That's a reference angle. It's just the angle from the smallest angle, the x-axis, to your line. Excuse me. More specifically, this line that you make, right? When you go all the way around and you make this like this line, this is what we call the terminal line. Terminal meaning like ending, right? So you can draw all the way to that line, and that's where your angle ends. So the reference angle is the smallest angle from the x-axis to your terminal line for your angle. Okay. So keep that in mind, and that's also how, if you remember the first quadrant, you'll always know the others. So I'm going to use that concept here. So pi over 6 for here. This should be 5 pi over 6. This is 7 pi over 6. I believe 11 pi over 6. Pi 6, okay. So pi over 6 as the root 3 over 2 comma 1/2. And the other three, right? This one, oh, this one, and this one, they all have the same reference angle. So we know that they all have the same, constants or absolute values, if you will. But then the question is, oh, what sign do you want to give them? In the second quadrant, we give a negative to the x, the cosine. In the third quadrant, we give negative to both values. In the fourth quadrant, we give the negative to the y or the sine value. This also, and we repeat this process for the last angle you usually have to remember, and that is pi over 3. So like this. Wait, this is a rough sketch. I'm not drawing this super perfectly. It should look close enough. There we go. So this is pi over 3. Oh, I'm still in dotted line. Okay, this is pi over 3. This is 2 pi over 3. Yes, 2 pi over 3. I haven't done this in a while. 4 pi over 3. Oh, that's a terrible pi. Pi over 3. And then this should be 5 pi over 3. Okay. So for pi over 3, your values are 1/2 comma root 3 over 2. And again, same thing. The other three values, angles, right? They have the same reference angle. So they'll use the same values, but we will change the signs according to the quadrant. Fourth quadrant needs a negative for the sine value. Third quadrant needs negatives for both. And the second quadrant needs a negative for the cosine value. And then you cannot forget about your, what do you call them? Your zeros and ones, essentially. So here, if angle pi, and this is pi over 2, well, pi over 2, Down here it's 3 pi over 2. So on this point, this is 0 or 2 pi. Here is 1 comma 0. This is negative 1 comma 0. This is 0 comma 1. Down here we have 0 comma negative 1. And this is the full unit circle. It's a quick review, right? For supplementary angles, they add up to 180. So supplementary means they add up to 180 degrees or pi radians. A complementary you add up to just 90 degrees or pi over 2 radians. And remember the unit conversion between radians and degrees, right? If you have degrees, you'll multiply by 180 over pi to get your radians. And to radians degrees, you do radians times 180 over pi, and you get degrees. Very simple. Right. So with this being drawn, we can do the next question. So, question 1 has us evaluate the 6 trig functions for the following angles. Okay. So, for pi over 3, right? If you only remember pi over 3, then you know that pi over 3 gives us, So, for the reference angle, right? For the reference angle, we want the smallest angle for the x-axis, right? So 4 pi over 3, if we draw a graph, right? We know that it's somewhere around here, right? It's not that far, is it? No, it's about that far. It's between pi and 3 pi over 2, right? And this is 4 pi over 3. This reference angle here is 4 pi over 3 minus 3 pi over 3, right? So pi. So this is pi over 3. So our reference angle is pi over 3. And from this, we know that we should have a cosine value of 1/2 and a sine value of √3 over 2. But we need to remember what quadrant we are in, right? So 4 pi over 3 is in quad 3, right? So it has the values instead of negative 1/2, negative √3 over 2. So for sine, we have negative √3 over 2. For cosine, we have negative 1/2. Okay, tangent, right? Tangent is sine over cosine, right? And thus, tangent in this case, right, would be negative √3 over 2 over negative 1/2, which is √3 over 1 when you multiply top bottom by negative 2, and you just get √3. So this is square root of 3. Okay. Cotangent is the inverse of tangent, so you get 1 over √3. Or you can rationalize that if you want, and you'll get I need to write a little smaller. And you'll get √3 over 3 for cotangent. for secant, right? Secant is the opposite of cosine. So let me draw some arrows to correlate. So these two are the opposite. It's kind of weird because secant doesn't have the co in front of it, but that's just how it works. So you flip -1/2, just the numerator and the denominator, you get -2, right? -2 over 1, which is -2. For cosecant, weirdly enough, this is the reciprocal of sine. So you get -2 over root 3, which is -2 root 3 over 3, I believe. I cannot math today. Yeah, this is the answer. There you go. Okay. Excuse me. What's next? Okay. So for 3/15, right? Let's convert this into radians. There we go. So 3/15 over 180, right? This is terrible math. This is divided into 15, so it'll be 21 times over 15. So this is 7. Wait, no, what is 3/15? One second. It's not 15, is it? So I'm dividing by. Oh, I'm dividing by 15, so this is not correct at all. Trying to think. We'll just work it out. So 3/15 divided by 15. Get 2, 30, 1, 5. So that's 1. 180 divided by 15. Get 1, 15, 3, 0, 6. Oh, 16. Okay. Doesn't seem very accurate. Something wrong with my math. Wait. Oh, it's 12. Okay, yeah, I can't math today. Okay, so 12 makes a lot more sense. Divide both sides by 3 and you get 4. Okay, so you have 7 pi over 4. If we drew a graph for this, 7 pi over 4 is right here, dead center. 7 pi over 4. We have 2 pi over here, and we have 3 pi over 2 right here. And the reference angle from here to here, right? This is 2 pi minus 7 pi over 4, which is 8 pi over 4 minus 7 pi over 4. This is pi over 4. So my reference angle, sorry for sniffling, my reference angle is pi over 4, which has values of root 2 over 2 and root 2 over 2. Now, since I am in quadrant 4, right? This is quad 4. I need a negative on my sine value. So it'd be root 2 over 2, negative root 2 over 2. But if you have time, it might be useful to just draw your own unit circle, or maybe just like the first quadrant of the unit circle, so you don't have to risk on remembering every single time. So with that in mind, right? With this in mind, that means I need to zoom out. Oh my gosh. My sine is negative root 2 over 2. My pen is dying. And my cosine is positive root 2 over 2. Tangent of 315, right? So this is, again, tangent is sine by cosine, right? And they're actually the same except for the negative side. So the tangent is negative 1. Okay, cotangent, right? It's the inverse. Oh, not inverse, the reciprocal, right? But if you flip, so 1 is 1 over 1. Now you flip them, you still get 1 over 1. So you get negative 1 still, okay? Secant goes with cosine. So you get 2 over root 2 when you flip, which is just 2 root 2 over 2, which is root 2. I wish my pen would stop doing this to me. There we go. And cosecant goes with sine. So you flip, you get negative 2 over root 2. This is just negative 2 root 2 over 2. And this gives you negative root 2. And that is how you use a unit circle to find all of the 6 major trig functions. Okay. And with that, that concludes my video on the unit circle and the angles.